That's your constructive interference. Wave A going to the right, B to the left. They meet and add. So one was 2 blocks, the other was 2 blocks. So now we have a 4-block one. And then they pass through each other. So B is left and A is right. They're both 2 blocks like they were before. Okay. Interestingly enough, if it's 1 and 3, they would add up to 4, pass through each other, and still be 1 and 3. If it's 2 and 7, they would add together, be 9, and pass around, and still be 2 and 7. So they always add together. A little bit, yeah. Yeah, same kind of idea. And for the same reason, energy has to be the same. Can't change. So it's got to be what it was before. All right, so now we get to destructive interference. Okay, so with destructive interference, let's see. Trying to make sure I have enough room for the other one. Okay, so here's mine. Yeah. I'm having Raj's flipped over, even though technically I flipped it over, but no worries, same idea. Okay, here's his going that way. All right, when they meet in the middle, here's mine, +2, going to the right. Here's his, -2, going to the left. But that means A plus B cancel. For that one split second, they cancel each other out. But then they keep traveling the way that they were. So his, -2, traveling left. Here's mine, +2, traveling right. So again, you can see why it looks like they cancel, but they don't actually. They just pass through. All right, last thing I want to look at here is standing waves. Okay. Raj makes a wave, looks like this. Okay, and his is traveling this way. I make the exact same wave that he does. So mine looks like this. So where his is a crest, mine is a crest. Where his is a trough, mine is a trough. So what type of interference is this? Constructive interference. Excellent. This is not concerning. Okay, so we got constructive interference. That means when they add together, I'm going to get a really big wave that's going to do this. Huh? Oh, everything. Economy is magically fixed by constructive waves. Yeah. Okay, so that's what happens. But these waves are traveling down the slinky. So that means the next second, his has changed a little bit. So it's moved this way. So instead of it being at a crest here, it's now a little bit lower than a crest. All right, so the crest would be here. It's here. Okay, so it's kind of like this. Okay, mine's also traveled a little bit. So mine's also a little bit different. But mine is going to look like this now. Always. Now what's going to happen? What type of interference? Destructive interference. It's going to cancel. But then they're going to keep going again. Okay, I'm going to draw these a little bit smaller just so they fit on here, but I'm going to do it like before. So instead of it being his at a crest now, his is at a trough. And it's going to be like this. Yeah, it gets smaller every time because your teacher runs out of space. And then mine's also at a crest now.
What's the difference?
So now what would happen is it would be the opposite way. So notice that it went from really tall crests and really big troughs to nothing to really big troughs with really big crests. They just keep flip-flopping. So it would go to this, to this, to this, to this, to this, to this, to this. And that's what you saw, that flip-flopping motion. That's what was happening here. So standing waves are just constructive and destructive interference. So if I ask you what causes waves, are standing waves, that's what causes them, constructive and destructive interference. Okay, that's all that causes. Okay, that's the idea behind them. Anyone have any questions about constructive or destructive or how those things overlap with each other?
Why do you, when you get the destructive wave, why do you still get, why do you still see movement? Like when you're moving.
Why does it look like there's some motion still?
Yeah.
Are you talking about why do they keep going?
Like, they just keep.
Why do they keep going?
Yeah, they just still
So part of it is Raj and I weren't making exactly the same wave. So because our waves aren't exactly the same, they're not going to overlap perfectly. But the other reason is energy can't be created or destroyed, right? So when those waves overlap and their energy adds to zero, there's still energy there. So if it all of a sudden stopped, that energy would have disappeared. Right? So if I have a positive wave and a negative wave and they met and they canceled and that was it, all of a sudden that energy's gone and we don't know where it went. And that's impossible. So that's why they keep going afterwards. They keep going afterwards because if they canceled and stopped, that wouldn't happen. A great example of this is if you're listening to noise-canceling headphones. Okay? So the original noise-canceling headphones, we'll talk about this when we get to the next thing on sound. Original noise-canceling headphones were made for business people on airplanes. And so what they did is they took all the sounds that airplanes make. They took the person snoring next to you, they took the air coming through the air vents, they took the vibration of the fuselage, they took all those sounds, and they took what they were and they made the exact opposite sound. And then you would turn them on, and it would get rid of all those sounds. Did it actually get rid of them? No. It had one wave like this, it created another wave like this, and they were constant. You constantly had those sounds coming in. You constantly had the sounds from the headphones going out, and they would cancel each other in your ear. And so if you took off the headphones, those sounds are still there. Okay? If you magically made the sounds from the airplane disappear, you would hear sounds coming from the noise-canceling headphones. If you've ever been in a quiet room and turn on noise-canceling headphones, they make noise. Okay? And it's like just background noise, but they make noise. And so that's why they can't ever really cancel, because they're just continually making those waves. They overlap with destructive interference, but they aren't gone. Noise-canceling headphones today are slightly different, but those original noise-canceling headphones were a genius how they came up with them. Just a terrific idea. And yeah, that's why those ones are still dressed.
So you said they took like people snoring and like all the different noises.
Yeah.
How do you make the opposite of someone snoring?
So when I say opposite, I just mean shifted. So like Raj made a crest where I made a trough. So you take the exact same frequency and you shift it so that instead of it starting with a trough and ending with a crest, it starts with a crest and ends with a trough. So you're just inverting the sound wave.
What type of wave is this? Yeah.
Oh.
Thank you. Did it
I didn't have a
question.
Bad wave. How's the quietest room made?
Oh, the stuff around absorbs, yeah, it absorbs all the sound. So the reason you can hear me, most of the sound that you hear is bouncing off the walls. Like, you're hearing the direct sound from me. The Evangeline is mostly hearing me because the sound is hitting the back wall and bouncing her. That's mostly why she's hearing me. In, like, quiet rooms, they absorb that sound. It doesn't bounce off, so you don't hear it. And it doesn't resonate in the room, so you don't feel that like extra vibration. So it feels like nothing's happening.
So how do noise canceling headphones work to that?
So they are more generalized. So they have a more general range of sounds they produce. They're not specific. Like I said, like those noise canceling headphones were really only good on airplanes, because that's what they were designed for. If you went anywhere else, you would hear like that fuselage noise isn't canceled by anything else. So you would hear that anti-fuselage noise in your ear. Nowadays, they're much more generalized. They also use more technology as far as detecting what those sounds are and then playing them back. It uses similar technology to like in-ear monitors for like fans and stuff.
Okay. So you know the room that like is an oval, and like how you can stand on one side or the other, and you can like talk to somebody.
It uses resonance and reflection, which we'll talk about next unit. But yeah, it basically the sound resonates at a very specific location, and that very specific location is like on the other side of the room. So like if we're all talking normal, you wouldn't be able to hear me over there if I'm just in a random spot. But if I stood in the exact spot, identical to yours, then you would be able to hear me, even if I'm talking normal, even if everyone else is making, or whispering. You would be able to hear everything normal. Yeah, we're going to talk about that with sound in the next unit. Any other questions on this stuff?
Why'd you write so small?
Because I'm awesome.